All right, we're back. Notice I have gloves. I also have tongs for handling the dry ice because carbon dioxide right now, it's even at our 1 atmosphere pressure, it is a negative 109 degrees Fahrenheit.
Whoa, that's low.
Yeah, negative 78 degrees Celsius. So here we are. You can buy it at the grocery store. Folks even there have to handle it carefully. I'm putting some solid blocks in it. And if you want to take a close-up,
first.
for sure. And what we're going to do is I'm going to be showing you an experiment that we're going to get to see what happens to carbon dioxide molecules as they expand and we see sublimation happening. So watch what's going to happen here as I put some warm water.
Worm? What happens if you put boiling hot water?
Okay. Do you see what's happening?
It's like witch's fog, like from those like stews that you get.
All right.
Whoa.
And it is kind of appropriate Halloween time. I'm putting some liquid soap along the top because we're going to be watching what will happen when we have a soapy film over the surface.
Wait, what?
Okay, now, Helena, you might want to get down at an angle so you can see what is growing here.
Oh my
As those carbon dioxide molecules are speeding up, they're going away from one another. We are getting a...
Can I pop it? Can I pop
sphere.
it?
It's going to pop on its own.
I want to pop it.
As that soapy film is expanding.
Whoa.
Mihal, do you see this? Yeah. As that soapy film is expanding and stretching, we'll see how much it can be stretched before it can pop.
And then can we do it again?
Sort
or
of
is that not
a very appropriate Halloween-esque crystal ball.
Or you could
but it also is just a lot of fun. And so you can gather that once
definitely for
it gets popped,
hey, Mom.
it's almost, there's no way the surface tension can handle too much more. All right. So now, what I want you want to try it again?
Yes, please.
All right. Well, we can add a little bit more water so it continues to react.
Ooh.
And you can see it bubbling.
Oh no. Let's hope it continues.
So perfect.
Oh my. I know. We need more because or else it's not going to blow a bubble.
Well, and I needed to make sure I have a nice smooth rim with sudsy parts
Now,
on.
make sure to wear gloves at all times when you're handling it, because you may get hurt.
What would happen if you were to touch it?
Are you holding the camera nice and steady so you can see as the gas is expanding?
Mom, as she asked, what would happen if you were to touch it?
Not just freezer burn, frostbite. It burn you just like some really hot water.
Have you
might
ever
burn you.
accidentally touched?
No, thank goodness, no. Because a frostbite is no joke. It's actually going to be death in the cellular tissue. That would it's painful and it would take a while to recover.
So yeah, let's talk about the happy stuff. Okay?
Let's talk about the happy stuff. So we're watching it. We could experiment a little. Right now we're kind of having some background information. These things have been done for many classrooms and experiments and shows. But what I want y'all to think about is, so as we're playing and learning in a safe way, what could we have as variables that we would actually test and measure and see how they would change? So for example, with our crystal ball here, what would be something that we could experiment with to see about getting different size?
Oh, maybe you could just like
Different size bowls. I think that's what
Size
we would
bowls we could try to see how that might impact the crystal ball. Any other ideas?
Amount of dry ice.
Amounts of dry ice we could
What
vary
about
to measure.
color for the
And what
prettiness?
would we actually measure if we controlled as an independent variable that amount of dry ice? What would we measure?
How big the bubble is growing.
Perhaps there you go.
And how much soap too.
So now I'm going to be setting up another quick experiment that we're going to watch. This time we have a soapy solution that I'm putting inside my
This is still going. Can I pop it?
Oh, you can watch it as down here while it pops. It'll look so cool.
And do you have your eye on that graduated cylinder as well?
Mom, put on your gloves.
Well, I'm using the tongs.
Is it okay if you accidentally touch the smoke?
The smoke's fine. All right, let's see here. Let's see which one fits. So that one fits.
It's okay. So
How do they get a hold of dry ice? Like,
You hear that? That's because the metal coming in contact with the dry ice warms it up.
what is how do you get
hear
dry
that?
ice? Like, what is dry ice made from?
Oh, that would be something else for us to look into.
but like,
But
how
now,
do they make it?
I want to know if you guys can predict what's going to happen when I pour this soapy solution.
Is it gonna be
into-
bubbles? Bubbly coldness.
Let's watch.
Whoa!
Back up so you can see the whole
Don't touch
thing.
it. Just don't touch the tube. I don't want it to be too cold.
Well, and I was hoping that we would get to see what we saw in class today, which is a bubbly solution that would typically make bubbles. The carbon
I don't see
dioxide
any though.
would be making enough bubbles to bubble up and over.
I can see the
Just
bubbles
the
rising.
Dry ice looks like an iceberg almost.
The bubbles are rising from the bottom. I wonder what that's gonna
Yeah, it's not doing the bubbles quite the same way. Now, in school, I was using an Erlenmeyer flask, which has a nice large amount of surface area at the bottom. And you can see some of the bubbles starting to grow. Here we go. There it goes.
Whoa!
You can back up to take a look, make sure you get the whole thing in there. And it was interesting that it took a while in this case for the pressure to build up such that it would begin to... Yeah, you can touch the bubbles. The bubbles are fine to touch. They're just filled with what kind of gas? What's inside those
Carbon
bubbles?
dioxide.
Carbon dioxide, that's right.
Ooh,
It's what we breathe out.
That is what we breathe out.
This is so cool. Except it's kind of soapy.
Well, yeah.
It is from
it's
soap.
Dawn soap.
But how did they like create? How did they create dry ice?
You know what? It's got to be under a pressurized system, and being able to have carbon dioxide under pressure to have it as a really low temperature.
Can dry ice melt? I just want
So
Yeah.
I had heard a student was sharing that they read that they could spray a fire extinguisher, which is going to be under having, which you know what, I would have to investigate a little further. All right, signing off for today.
Bye.
Happy Halloween.